Hello and welcome. This is Joel from our marketing team. In today's episode, we will talk about the founding of NovaCast, as well as we will talk about the creation of ATAS. This means that with me today, I have NovaCast's and ATAS founder, Rudolf Sillén. Very welcome, Rudolf.
Thank you.
And with us today, we also have André Kump, who is technical manager in metallurgy at NovaCast, and who has great insight into ATAS development nowadays. Very welcome, André.
Yeah, thank you.
First of all, Rudolf, you are the founder of NovaCast. Can you tell us a little bit more about yourself and your background?
Yes, so I became a foundry engineer 1965. I think I graduated as number one, the whole school there. And then I was employed by Volvo. So Volvo has the biggest foundry in Sweden. At that time they made about 100,000 tons yearly. And I was employed as a development engineer. And that meant I could make a lot of experiments without anybody asking why, and I learned a lot. So I was there 7 years. Then here in Ronneby there was a Kockums foundry, which at that time was the largest jobbing foundry in Sweden. So we had 400 people making 25,000 tons, and I was employed as a foundry manager. And during that time and those days, you know, a lot of decisions in the foundry, how to make gating systems, if we should add a riser or not, was, you know, tacit knowledge, you know, like that. And I said we could do it like that or that. So very little calculations. And I was more interested, you know, in making calculation in science. So I developed, you know, some programs that we could calculate by hand. And then I bought, you know, a micro calculator, HP, also calculator that was programmable, and developed some systems. And in fact, you know, that was the start of NovaCast, because a lot of friends, they came and asked, can we buy this software? And I said yes. So that's when I started.
Okay.
And you know, this first micro here was in modern castings, and the year was 1983, and I believe it was the very first company who developed something for the founders using software.
Interesting.
Yeah.
So you can say that that was at that point.
That was a starting point at NovaCast, and the name Nova is Latin for new, and cast is castings. But you know, in movies you can see cast in order of appearance. So I mean, we could have different roles. We could be involved in a lot of things, not just foundries, but later on also in artificial intelligence.
And what was your goal with the company when you were starting NovaCast?
Well, the goal was to be able to develop software systems to improve technology in foundries. And also to have fun.
Yeah.
And do the things that I like to do, you know.
Yeah. And NovaCast has undergone a major change, not at least when it comes to the development of its products and the brand when it comes to sustainability. How do you see NovaCast as a company today?
I am very impressed what you have done since I left. I think I left 2009, and you have developed all the software. I mean, we had the Metal Master you have developed, the foundry technology you have developed, and NovaFlow and Solid, of course, and of course ATAS. So I think very positive.
And André, as I mentioned before, you work as a technical manager in metallurgy at NovaCast. what would you say that Rudolf contributed to in relation to the creation of NovaCast and the creation of ATAS?
Yeah, we have a limited time, so I will try to be short, because I mean Rudolf Sillén is one of the biggest name in the world regarding thermal analysis, and he's definitely a pioneer in this area. So I'm really privileged to sit with you now and talk to you, and it's been a long time, but definitely it means a lot for NovaCast. As I said, he's a pioneer and one of the best researcher out there, even up to this day. I'm reading a lot of papers, and I still see a lot of your name mentioned in many papers, and you've been referenced in many papers. Still up to as I said, just recently I read a paper from Stefanescu, a really known researcher, and you've been mentioned just recently. So overall, Rudolf Sillén for NovaCast means like a father, I would say. So whenever I go around with my colleagues, when we present NovaCast, we always speak highly of Rudolf Sillén, as we should, because he is NovaCast father and father of ATAS MedStar, absolutely. So.
And Rudolf, now we know more about the founding of NovaCast, and that makes me curious about how you view the creation of the first version of ATAS. So please tell me what was the original idea of ATAS?
So at that time, about around 1980, thermal analysis was limited to pouring samples that solidify white with cementite. And I saw, that with the cementite, okay, you could calculate the liquidus temperature and carbon, silicon roughly, but no more. And I mean that knowing that and also knowing chemistry, then you are a blind foundryman. Because you can have, the chemistry might be okay, carbon, silicon, manganese, and you maybe have 2% scrap and you're very happy. The next day you have the same chemistry, but now you have 15% scrap and nobody knows why. So that, I mean, with just chemistry you are blind. You just see what you have in there, how much carbon, etc., but not how they are connected, not what happens during solidification. And the most important is how carbon that is dissolved in the metal, how it precipitates. Does it come out as nodules or as spheres, and how many, etc., etc. That is the important, and that's why we started developing, so we could pour cups without tellurium, so we could see the gray solidification. And the first attempt was together with 5 Swedish foundries and the Swedish Foundry Association, because they started on a program, and we had a standard piece. So all these foundries, they poured this standard piece. And also I got, the chemistry and everything there. And I developed a program in BASIC, so we could take up the cooling curve and first derivative. And there I identified points that was easy to see, like, when you have the liquidus, the low eutectic, etc., etc. And then I used artificial intelligence technology, today what is called machine learning. So you can, as example, enter all this data and then the outcome, if it was a shrinkage or no shrinkage, because that was the main purpose of the first. And then I could see which factors that influence the macro shrinkage and micro shrinkage. And that's really how it came about. So, I think NovaCast was one of the first to use artificial intelligence in the foundry. And this is from Modern Casting, 1991. So I think we were one of the pioneers. So with this, it could develop decision trees. I can't see very well here, but here you can see it could find out which is the most important factor, what are the threshold values, etc., etc. And these rules were then put into ATAS. And then we saw we must make it different for different foundries. Because in a green sand foundry with very weak molds, if you have too much graphite expansion, that would be bad. But if in a furane foundry, that would be good. So we developed the possibility to have it for different alloys. So that made hence the name ATAS, Adaptive Thermal Analysis System. So
and what kind of impact would you say that ATAS had on the foundries in the 1890s?
Yeah, I think it had some impact. Starting point was a little slow, mainly here, Swedish foundries. But we also precipitated in exhibitions in the States. And then, it started to rise. So.
And if we look at the current ATAS Metstar 10.3 version, Andrei, how would you describe that ATAS Metstar 10.3 is constructed today?
Yeah, before I get to what we have today, I have to lean back to what Rudy said about the basics and how it came up actually, and we use many things from ATAS which was developed by you, and we still use it to this day, and worldwide users, customers are using ACL, for example. I mean, this is one of the most beneficial feature which we have in ATAS Master, ACL, active carbon equivalent. And this is what we actually can make a profit, a huge profit, to avoid shrinkages, macro shrinkages, etc. So, but yeah, if we go to the version 10.3, which we have today, what we are focusing in the last, let's say, since I am more or less in charge of ATAS development, I try to focus on how to make ATAS Master user-friendly for operators and for engineers, because we are building on 2 levels as it was. So we just try to expand this. So first level is for operators. It has to be a simple information, MQ, based on MQ. If MQ is high, we will have a green light. If it's in between, we will have an amber light, and if it's really low quality, meteorological quality, then we have a red light. So this is a simple but effective information for operators. And then the second level is more engineering level, where we have mastermind. For example, this is a linear correlation, finding out parameters which are determined by ATAS Master, and with some other information, let's say perlite content, or maybe shrinkages, etc. So we are finding this. So 10.3 ATAS Master is a quite unique tool. We are connecting to many different equipment inside of a melting shop, in-stream inoculation machine, to spectrometer, for example, to grab information from spectrometer, from temperature lens, and use this information to actively give information to operators, such as amount of magnesium addition, etc. So we are trying to make ATAS Master as a heart of melting shop. So the information goes in ATAS Master, use it, and give information out, and to make it as less human error as possible. human error is such a common thing which we have in melting shop, and we try to make automatization. So this is what I'm trying to develop for many years. Make ATAS Master more user-friendly, and automatization, avoid human errors. So this is a little bit in ATAS Master and in 10.3 as well.
And now I'm asking both of you, would you say that there are some features left over from the first version of ATAS to the current ATAS Metstar 10.3? Rudolf, how do you see
Yeah, I think some, like Andrei said, some of the basic are still there, of course. But then he has developed a lot of very nice features. So, and not least, the possibility to save it in the database and things like that, to communicate with a spectrometer and things like that. So it's a very impressive development. Very good.
Thank you so much, but I must say that basics, what you have developed in ATAS, it's still here and we use it every day.
Yeah.
All of our customers are using, so there are many things that it's been for a while around, but it is what it is. If it's a good development, why change? We always just improve, So yeah, absolutely. We still have many things in ATAS Metstar which was used from the beginning. So, and that's to do. Rudy, as I said, it's a pioneer on this area. So you cannot beat his knowledge,
And now we have looked back in time and we have talked about the first version of ATAS, as well as we have talked about the current version of ATAS Metstar 10.3. But if we take a look in the future, Rudolf, what do you think about the future of the foundry industry, and what significant role will ATAS Metstar have in the future?
Yeah, I think it will be more of this artificial intelligence in the dialogue with the foundry guy at the melting platform. So maybe he can talk to ATAS. ATAS, can you tell me how much carbon I should add to this melt? Yes, you should add about 120 kilos. And so forth. I think that would be one development. And also, I think, which you already have, it's that communicate with, for instance, NovaFlow and Solid. So some data from ATAS can be used to tweak NovaFlow and Solid to exactly match that melt, to make a good prediction of shrinkage, etc. So I think those are some of the guidelines. And also maybe combined with the Metal Master for optimization, not just cost, but also for the environment, like NovaCast with the footprint, to
CO2
reduce, the carbon dioxide, and maybe then to avoid having melts standing in the furnace for hours and using electricity. But maybe with ATAS you could find the perfect analysis within 5 minutes, just before you should pour. Many small things.
Yeah, absolutely.
And Andre, do you agree about Rudolf's thoughts, or
Absolutely.
how do you see?
I mean, we are doing what we can to lower the cost on the charged material with Metal Master, with calculation of CO2 emission, environmental footprint, as we call it as well. And just this year, I think in Europe it's coming, it is a law actually. Till end of this year, all suppliers of materials has to provide CO2 content for each material, and that is what we will use in Metal Master and ATAS Master as well, to actively calculate CO2 emission per melt, for example, or per charge. So this is a little bit, and as we all know, electricity, it's really a big problem these days, you know, and this is all what we can also adjust with ATAS Master to have. I mean, why we would hold such a high temperature for a long time? If, for example, we have a stoppage in the foundry, why we should hold it at 1470 degrees? There is no point. Over time we lose quality, as well as consumption of electricity goes up. So we just lower it to equilibrium temperature, somewhere around 1400 degrees. And when we know it's close, the stoppage will be, or the foundry will continue to produce. So then we lift up to the pouring temperature and we go along. So this is things which can be and it should be used, you know, with ATAS Master. So definitely, if I sum it up, CO2 emission is focus, electricity, less material, less cost, less defects, less scrap, etc. So this is all the things we are doing with ATAS Master, Metal Master, and as Rudy said, connection to NovaFlow and Solid, our simulation system. So we combine these two systems and to have even better prediction of shrinkage positions and size of it due to the exact information that we get from ATAS Master. So yeah, exciting times, I must say. Challenging, but exciting times.
You know, when I was here and visiting customers, I made a presentation with PowerPoint, and my last picture was this: economical consequences. So I assumed here a foundry making 10,000 tons a year. Then you could, in yield improvement, you could save about 2 to 4%, and that would be saving about $60,000. Reduced consumption of inoculants and magnesium alloy could add $50,000, and total savings about 25. So that foundry would save $250,000 just by buying ATAS. So I think that, okay.
No, I totally agree. I mean, these days when you go to a foundry and you can make tests, you made a test, but at some point you will sit down with the decision makers and it's all about internal investment. How fast my investment will come back. And that is exactly what Rudy just showed us. So yes, that is how, okay, how much scrap you have today, metallurgical scrap, then we can say for certain up to 1%, we can lower it down to 1% easily. Then we can go even lower, but we have to be even more. So, and then also how much material. So this calculation is so fast and easy, and in most cases, return on investment is 6 to 8 months, depends on the size of the investment, etc. But up to 1 year, definitely. So in this case, it would be much, much faster. Yeah.
I think another benefit for the foundry personnel is that they will learn more about the metallurgy indirectly. So when they have ATAS, they will start ATAS at why, and they learn, you know. And after they've had ATAS for a year, they are much better foundrymen than before. And I think that's also an important.
Absolutely.
Yeah. It's online learning.
Yeah. I saw this in practice, and it, exactly as you said, you know, exactly. So operators, even on a basic level, they are just interested. Okay, what's the cooling curve? What does it mean liquidus? What's the T low? And then you explain a little bit, and then you come back in a couple of months, and then they have new questions, more interesting questions. So all of a sudden they are involved, and then they have even competition between each other who can achieve a higher MQ value, metallurgical quality value, and then it's a little bit competition in between, you know. So I mean, it's exactly, so it's really beautiful to see how ATAS can help overall knowledge and just lift up the common sense about importance of metallurgical knowledge in foundry.
Yeah,
Yeah. And gentlemen, I would like to thank you both for participating in this NCTV episode, as well as thank you for interesting input regarding NovaCast as a company, as well as your view of ATAS as a product now and then. So thank you very much for coming.
Thank you.
Thank you. Thank you.
Thank you very much for watching this episode. Take care and do not forget to follow us at LinkedIn, Facebook and YouTube. Bye.